In this presentation, we have talked about hydrogen atom. Hydrogen atom has few peculiar properties. The only element without a neutron is hydrogen. If I write hydrogen, it is H11 Z equal to 1, the number of protons. Then mass number is also 1. This is atomic number, this is mass number. We know that mass number is equal to Z plus N. Proton number plus neutron number. Then N is equal to A minus Z. In the case of hydrogen, A equal to 1, Z equal to 1. So N is equal to 0. Simply we can point out that the only element without a neutron is hydrogen. Furthermore, the potential existing in the case of hydrogen is coulombic. V of R is equal to minus Z square divided by R. This is the potential of hydrogen atom. The prime question is, how do you write V of R is equal to minus Z square divided by R, since the potential is coulombic in nature? Now we have to apply our Coulomb's law. Say a nucleus of charge plus Ze. This is our hydrogen atom. The charge is plus Ze. Atomic number is 1 unit. The charge is plus Ze. This is the charge of the nucleus. An electron is orbiting around this nucleus at a distance r. See this electron of charge E minus, which is at a distance of r. According to Coulomb, F is proportional to Q1 and Q2. F is inversely proportional to square of the perpendicular distance between them. Here F is proportional to Z into minus C. F is inversely proportional to R square. Then F is equal to minus 1 by 4 pi epsilon naught Z into minus C. That is minus Z square, so that we have avoided this negative sign, divided by R square. This is the force. F is equal to minus 1 by 4 pi epsilon naught Z square divided by R square. This is a constant term. So consider F is equal to minus Z square divided by R for simplicity. R square. This is the force existing between the two charges. We know that gradient of negative potential is force dV by dr. This equation is present in our mathematical physics as well as classical mechanics. Work done in moving a unit positive charge from infinite distance to a particular point is called the potential at that point. We need the value of V. Here, minus dV by dr, which is equal to minus Z square by R. Because force equal to gradient of negative potential. Minus dV by dr is, here force is minus Z square by R. Then dV by dr equal to Z E square by R square. Here the force value is minus Z square by R square. From this dV equal to Z E square divided by R square into dr. If you want to find out the value of V, just you have to integrate this. Z E square constant dr by R square, limit varying from infinity to R. Work done in moving a positive charge from infinite distance to a particular point is called potential at that point. Here the distance of separation is R. Infinity to r is the limit. Now we have to integrate this. V equal to z e square. This is actually r power minus 2. Integral r power minus 2 dr z e square r power minus 2 plus 1 divided by minus 2 plus 1. Limit varying from infinity to r. This is z e square r power minus 1 divided by minus 1. If you put the upper limit r power minus 1 divided by minus 1. And also keep the limit. Finally, we will apply the limit. This is r power minus 1 is 1 by r. Keep this negative sign here. Minus z e square divided by r. Now apply the limit. Upper limit r, lower limit infinity. Minus z e square by r. Minus of lower limit. Minus into minus plus z e square divided by infinity. Anything by infinity is 0. So this is the potential value. Potential value of hydrogen atom is minus z e square divided by r. In the case of hydrogen atom, the potential V of r is equal to minus z e square divided by r. In this way alone, we have arrived at the potential. So the potential is Coulombic. Now to solve the energy eigenvalue of hydrogen atom, we have to write a Schrodinger time independent wave equation in terms of r, theta and phi. So this is equation 1. Just we have expressed the del square operator in terms of r, theta and pi. 1 by r square dou by dou r square dou psi by dou r plus 1 by r square sin theta dou by dou theta, sin theta dou psi by dou theta plus 1 by r square sin square theta, dou square psi by dou pi square plus 2 mu divided by h cross square. In t minus 3 the psi equal to 0 is the required Schrodinger equation. Now we have to write the solution for this equation 1. The solution is psi equal to r of r, capital theta of theta, then capital pi of pi. This is a solution for the above equation 1. This is capital R. It's a function of small r. Now replace psi by means of r of r, theta of theta, pi of pi, and divide each and every term by the same r of r, theta of theta, pi of pi. This is 1 by r square, capital R, dou by dou r of r square, dou capital R divided by dou small r, plus 1 by r square sin theta into capital theta, dou by dou theta, sin theta, dou capital theta by dou small theta, plus 1 divided by r square sin square theta to 1 divided by capital pi, dou square capital pi by dou pi square plus 2 mu by h cross square into e minus v equal to 0. So this is equation number 2. See here, I have replaced the psi by means of r of r, theta of theta, pi of pi, and divide the first term by the same r of r, theta of theta, pi of pi. Here, r of r is a function of small r, so dou by dou r of r is meaningful, but theta and pi are constants. Therefore, if you divide the first term by r of r, theta of theta, pi of pi, theta of theta, pi of pi is cancelled out, but r is kept as such because r is a function of small r. Here, Theta is a variable. So theta is kept as such, remaining two terms, r and pi are cancelled. Here pi is a variable, so pi is kept as such, then r of theta cancelled out. Here all are cancelled. Psi is replaced by r of theta pi of pi, whole divided by r of theta pi of pi. Entire is equal to 0. See this equation 2. This term is carrying r square sin square theta as an additional one. If you remove this r square sin square theta, we can expect other terms in terms of pi alone. See this equation. We should replace this r square sin square theta. Then only we can get this term in terms of pi only. Therefore, multiply equation 2 by r square sin square theta. Now, sin square theta by r, dou by dou r of r square dou capital R divided by dou small r plus sin theta divided by capital theta. R square sin square theta, r square cancelled out. Sin square theta by sin theta is sin theta divided by capital theta. Then dou by dou theta, sin theta dou capital theta by dou small theta plus 1 divided by capital pi. Dou square capital pi divided by dou pi square plus 2 mu r square by h cross square e minus v sin square theta entire is equal to 0. Say this is equation number 3. Not 3. Say this is 2. This is 3. This is 4. Therefore, multiply equation 3 in r square sin square theta. Now see the equation 4. We may keep r and theta term to the left hand side and shift the pi term to the right hand side. Sin square theta divided by r, dou by dou r of r square dou r by dou r plus 2 mu r square by h cross square e minus v sin square theta plus sin theta divided by capital theta dou by dou theta of sin theta dou capital theta by dou small theta, which is equal to minus 1 divided by capital pi dou square capital pi divided by dou pi square. This is equation 5. See this equation 5. LHS is expressed in terms of r and theta, whereas the RHS is expressed only in terms of pi alone. This is possible only when both the sides are equal to a constant, say m square. In equation 5, LHS is a function of r and theta, whereas RHS is a function of pi only. This is possible only when both sides are equal to a constant, say m square. Just I have copied the two equations separately. Say this equation equal to m square and the right hand side is also equal to m square. Now we have to solve the pi equation. Now we have to get our pi equation. Now from equation 7, rho square pi by 2 pi square equal to minus m square into pi. Now from equation 7, dou square pi divided by dou pi square equal to minus m square into capital pi. Dou square pi divided by dou small pi square plus m square into capital pi equal to 0. Say this is equation 8. The solution to equation 8 is pi equal to a e power im pi. So this is 9. Now a is our normalization constant whose value is find out using our normalization condition. Pi star pi d pi is equal to 1. This pi star is a star e power minus im pi. Then pi is a e power im pi. Entire is multiplied by d pi equal to 1. Limit varying from 0 to 2 pi. A star a is a square. E power minus im pi into e power plus im pi is e power 0, that is 1. Integral d pi. Limit varying from 0 to 2 pi equal to 1. A square. If you integrate this, we can get pi. Limit varying from 0 to 2 pi equal to 1. A square into 2 pi is equal to 1. Then a square is equal to 1 divided by 2 pi. Therefore, a equal to 1 divided by 2 pi inside the root. Now the value of pi equation is 1 divided by 2 pi inside the root e power im pi. Say this is equation number 10. This is our pi equation. M is equal to 0 plus or minus 1 plus or minus 2 and so on. Now we have to solve the theta and r equations. To get the r and theta equations, multiply both sides of equation, divide equation 6 by sin square theta. See, equation 6 divided by sin square theta gives 1 by r dou by dou r of r square dou r by dou r plus 2 mu r square divided by h cross square into e minus v plus 1 by sin theta into capital theta dou by dou theta sin theta dou capital theta by dou small theta, which is equal to m square divided by sin square theta. We have to express equation 6 in terms of theta and r. For that, see this term. If you remove sin square theta, we can get other terms only in terms of r. See, if you remove sin square theta, we can get 2 mu r square by h cross square e minus v alone. Here also, additional term is sin square theta. If you remove this sin square theta, we can get these two terms only in terms of r. So that divide equation 6 by means of sin square theta. If you divide each and every term of equation 6 by sin square theta, the first term is 1 by r dou by dou r of r square dou r by dou r, and second term is 2 mu r square by h cross square e minus c plus 1 by sin theta into capital theta dou by dou theta sin theta dou capital theta by dou theta, which is equal to m square divided by sin square theta. Now first two terms are in terms of r, third term and right hand side is expressed in terms of theta. Now this is modified as 1 by capital R dou by dou r of r square dou capital R by dou small r plus 2 mu r square by h cross square e minus v, which is equal to m square divided by sin square theta minus 1 divided by sin theta into capital theta dou by dou theta of small theta sin theta dou capital theta divided by dou small theta. Say this is equation number 12. See the equation 12. The left hand side is expressed in terms of r, whereas the right hand side is expressed in terms of theta. This is possible only when both the sides are equal to a constant, say beta. In equation 12, LHS is a function of r only, whereas RHS is a function of theta only. This is possible only when both sides are equal to a constant, say beta. Just I have copied the equations and are allowed to equal a constant beta. In this way we have had the equations 13 and 14. Now we have to get our theta equation and the r equation. To get the theta equation, take equation 14 and shift the term m square divided by sin square theta to the right hand side. You can get minus 1 divided by sin theta into capital theta, dou by dou theta of sin theta, dou capital theta by dou small theta, which is equal to beta minus m square divided by sin square theta. Now bring all the terms to the left hand side. 1 divided by sin theta with a negative sign into capital theta, dou by dou theta, sin theta, dou capital theta by dou small theta, minus beta minus m square divided by sin square theta is equal to 0. Then multiply both sides with the help of a negative sign. We can get 1 by sin theta into capital theta, dou by dou theta, sin theta, dou capital theta by dou small theta, plus beta minus m square divided by sin square theta equal to 0. This is equation 15. Now multiply both sides of equation 15 by capital theta. Now we may get 15 equation 15 into capital theta. Then we have 1 by sin theta, dou by dou theta, sin theta, dou capital theta by dou small theta, plus beta minus m square divided by sin square theta. This is multiplied by capital theta equal to 0. So this is equation 16. This is called as a theta equation. We have had the solution already. In the case of rigid rotator, we arrived at the solution. To solve the theta equation, we are given the solution theta equal to b ln of cos theta. Here b is a normalization constant whose value is 2l plus 1 divided by 2 into l minus m factorial divided by l plus m factorial inside the root. Therefore theta equal to 2l plus 1 by 2 l minus m factorial divided by l plus m factorial entire is multiplied by plm of cos theta. So this is our theta equation. We have arrived at the same in the case of rigid rotator. So this is equation number 17. Now we have to get our r equation. To get our R equation, multiply equation 13 by R of R by R square. So the first term is 1 by R square dou by dou R of R square dou capital R divided by dou small r plus 2 mu by h cross square E minus V into R of R is equal to beta by R square into R of R. This is modified as 1 by R square dou by dou R square dou R by dou R plus 2 mu divided by h cross square into E minus V minus beta by R square entire is multiplied by R of R is equal to 0. So this is equation 18. Right. This is 1 by R square dou by dou R of R square dou R by dou R plus 2 mu E by h cross square minus 2 mu V by h cross square minus beta by R square entire is multiplied by R of R is equal to 0. So this is equation number 19. You know that the value of V of R is equal to minus Z square divided by R and beta equal to L into L plus 1. Now we have to substitute these two things in equation 19. We will get our R equation. Our R equation is modified as 1 by R square dou by dou R of R square dou capital R divided by dou small r plus 2 mu E by h cross square. V of R is minus Z square by R. So minus into minus plus 2 mu Z E square. Instead of V of R, we have to put minus Z square by R. Minus into minus plus 2 mu Z square divided by h cross square R, then minus L into L plus 1 by R square entire is multiplied by R of R equal to 0. So this is equation number 20. This is called as R equation. Now we have to solve this R equation to get the energy eigenvalue of Argand atom.